check this example. In this example, we already know the sample size. We have 1,487 adults, right? And we also know 43%. So that will be our best point estimate, p-hat, our proportion from this sample. So it's our p-hat. Okay, the question already listed the information here. So first question, A, we need to find the margin of error. And we know the confidence level, 95 as our confidence level. So if we know the confidence level, this is another way to tell us the alpha level. When we talk about the margin of error, we know by the formula, we need to get what is the critical value first. Then we can find the margin of error. And if we want to find the critical value, we always need to find what's the alpha value first. Then we can find what's the half alpha value. After that, we can use that one to check the Z critical value, right? And the second part B, we need to find what is the confidence interval. So let's do the first two parts first. Then we go back to check the last question. Okay. So of course, if we want to construct a confidence interval, we need to check if it's a binomial distribution, if all of the sample is simple random sample, all of the requirements should be satisfied, right? So in this question, we quickly go through this part. It's just the binomial distribution and all of the requirements are satisfied. So the first several slides to show you how to get the answer by using the technology. But in our class, we will focus on using the tables to help us to find the answer. So first step, we know the confidence level is 95%. So it's 1 minus alpha. From here, we can get the alpha value is just 1 minus 95%. It's 5%, so it's 0.05. But remember here, it's half alpha. Again, it's half alpha. Because confidence interval always gives you two sides value. So it will be 0.025. If you already memorize some use for critical value, you will already realize the critical value for 0.025 is just 1.96. And we already do it in the previous example, right? So we already find the critical value. If you forget what is the critical value, you can use this one as the right tail area to get the left side area, then check your table to find the critical value. That's also fine. But if you already memorize that special critical value, then you save time to check the table, right? So after we have the critical value, then we can directly use the formula to help us to get the margin of error. We know this is p-hat. 0.43 is the p-hat from the question. Of course, we know there's a relationship between p-hat and q-hat. We use 1 minus p-hat to get q-hat. So plug in the numbers, we will get this margin of error. Now, we will use the margin of error to complete the part B. Part B asks us to construct the confidence interval, right? So confidence interval for proportion always follow this format. P-hat, point estimate, minus margin of error to p-hat plus margin of error. So from the question, we already know p-hat, 0.43. And from part A, we know margin of error. So minus margin of error to plus margin of error. And that step, we only need to keep 3 significant digits for the answer. Make sure you know this is the format for the confidence interval of proportion. P hat minus plus margin of error. So let's check the part C. After we have the margin of error, after we have the confidence interval, we know it's just the confidence interval. Let's see. The confidence interval is from 0.405 to 0.455. Let's write down the result here. Let's check part C. Based on this result, so based on this confidence interval, can we safely conclude that fewer than 50 of the adults have Facebook? Assuming you are a newspaper reporter, write a brief statement. Describe this one. This time we want to talk about, is that true, fewer than 50%? Because confidence interval has 95% probability. We are 95% sure this confidence interval contain the true value of the P. And we know this confidence interval, the whole interval, are below 50%. The whole confidence interval are below 50%. So we can say yes, we can safely conclude fewer than 50%, because the whole interval fewer than 50%. So we can safely conclude fewer than 50% of the adults have Facebook pages. That's our conclusion. Let's check it together. So based on the confidence interval we get, the whole interval completely below 50%. So we could safely conclude fewer than does appear fewer than 50%. If we have the interval like this, let's see. We have the same question. This time, if we have this confidence interval, can we safely conclude less than 50% of the adults have a Facebook page? Can we safely conclude that? This time, part of the confidence below 0.5, but part of the confidence interval above the 0.5. So if this is the case, we could not safely conclude fewer than 50. In our example, we can safely conclude because the whole interval below 0.5. So make sure you understand it. So this is just tell you. You can quickly skip this part. This just tell you analyzing polls. So sample size should be is a small percent of the population size, but the population size is not the factor in determining the reliability of a poll. So you only need to know we have large population size, small sample size. That's enough for this reliability. You don't need to consider too much about this topic. So if we have the confidence interval, we only have the confidence interval, something like that. Can we get the point estimate? So this time we do not know the point estimate at first, but we have the interval. We have the lower limit and the upper limit of the interval. We could use this formula because we know this one is the P minus E and this one is P plus E. If we add them up, upper limit plus lower limit, we will get what? We will get 2 P's, right? We add them up, lower limit, upper limit, we will cancel out the margin of error, we will get 2P. 2P divided by 2, we will definitely get P hat. I will get 2P hats. Similarly, if we use this upper limit to minus lower limit, we will cancel out the P. We will only have 2E. Then E divided by 2, we will get the value of E, single E. So if we have the confidence interval, we can use this two formula to get what is the point estimate, what is the margin of error. So we can check this example. So this example, we do not have the point estimate and the margin of error. We only have the confidence interval. But we could use the confidence interval to find what's the P hat and what's the margin of error. So from the question, we know we have the confidence interval. And we know it's 95 confidence interval. So if we want to find what is the, so we list the confidence interval first. Then we use this formula. The upper limit is 0.81 plus the lower limit is 0.58 divided by 2. Divided the sum by 2, we will get this. This is our point estimate. And we use another formula to get the margin of error. We use the upper limit minus lower limit, then divided the difference by 2 to get our margin of error. So upper limit here is 0.81 minus 0.58, divided the difference by 2 to get the margin of error. So next topic will be the sample size. The sample size means we need to find the minimum sample size required to do the estimation. If the sample size is too small, then we cannot do the estimating. So there is a minimum sample size. So all the notations remains the same. So again, here the critical value is still the half alpha. Don't forget it. And we have this formula. Let me see, the formula seems not correctly displayed. It should have. So sometimes we have two formulas. Sometimes the point estimate is known. Then we could use this formula. This formula will need the value of P hat. If P hat is known, we can use P hat to get the Q hat value, then we can use this formula. But sometimes we don't even know the value of P hat. Then we treat P hat times Q hat as 0.5 times 0.5. Then we will get 0.25. If we do not know P value or Q value, we can use 0.25 to replace the P hat times Q hat term. So this one is just treat p hat, q hat at both 0.5. We'll get this 0.25. So we have two formulas for the minimum sample size. So the round-off rule is always round up. Even we just get 0.11, we still need to round up to next whole number. Okay, sample size, of course, should be a whole number. Let's check this one. We need to find the how many adults should be, it must be surveyed. So that means we need to find the minimum sample size. At least how many adults should be surveyed to estimate the confidence interval. So we know it's 95 confidence level. So we get alpha again is 1 minus 95% is 0.05. So half alpha again, we need to use half alpha, 0.025. So this is a special one. So I hope you can memorize this critical value is 1.696. Then we already know the margin of error, right? Let's check how can we find the margin of error? The last sentence here. No more than 3 percentage points. The error by no more than 3% of points, which means the margin of error is no more than 3. The maximum error is 3%, right? The error no more than 3%. So the maximum error, the margin of error is 3%. So we will use 3%, 0.03 as our margin of error. Of course, 0.8 is our p-hat, because from the question we know 80% make online purchases, which means 80% is the p-hat. 80% is our p-hat. If 80% is our p-hat, then 20% is our q-hat. So the remaining part is just use the formula to do the calculation. After that, we round up to next whole number. We will say at least we need 683 adults to do the survey. If we have too few people to do the survey, then it's not reliable to construct the confidence interval. So the second part, part B, said with no information of the sample proportion. So we do not know any value of proportion. So the remaining part is just the same. Only the p-hat, q-hat part we use 0.025 to replace that. So this time we have this answer. We need at least 1,068 people to do the survey. Then we compare the result from part A and part B. So we know part B need to collect more people to do the survey. So that means more information is good, right? Because part A, we have information about p-hat. Part B, we do not have information of p-hat. So we need to add more people to do the survey. No knowledge, which means no knowledge, then a larger sample is required. So that's all for the estimate of proportion. We talk about point estimate, confidence interval, and minimum sample size.